I've been asked to have a look at exercise 26.07. So that's from the theta probability section. So theta exercise 26.07 and question 1. A and B. So it says every time people use a liquid soap dispenser, the volume of soap produced is normally distributed. And that normally distributed bit, of course, means we're going to have a Gaussian curve or a normal distribution curve. So here we go, which is not particularly good, but we'll go with it. So here is our mean. So I've got a mu value here, and I'm going to have a sigma value here as well. My mean is 7 milliliters, so I'm going to write 7 in here, 7 milliliters, and of course my standard deviation is 1.5. Remembering really I should leave a gap in between the figures and the units. I didn't really do that here, so as I'm going through, I'm just sort of noticing my mistakes as I go through. Okay, and it says calculate the probability that over 9 milliliters comes out of the dispenser. So here's the mean at 7. We want to find out if more than 9, well, let's say that is 9 there. Let's say that's 9 milliliters. Yeah, this point here is 9. Well, we don't want 9, we want more than 9. Yes, so we want this bit here. So we want to find a way of calculating if more than 9 will come from the dispenser. Now, at the moment, the way we would normally do this, of course, is we would go to the normal distribution table, and we would take our z value and turn it into a probability. So all these are z's along here, all z's along here, but all the stuff in the middle here, all of these, of course, are probabilities. So we need a z value to turn into a probability, but we don't have z values, so we need a way of turning our units, in this case, which are milliliters, but they could be light years, they could be megaparsecs, they could be meters per second or degrees Celsius or whatever it happens to be. We want to find a way of turning units, which are non-statistical units, into standard deviations. And the way we do that is we get the z-score. Now, z's are just standard deviations. And when we have a z-score, we can find the probability of how far of the likelihood of something happening when it is a certain distance from the mean. So z is equal to x, and the x value, by the way, is the value. That's the value we're going to plonk in. That's the value of the non-standard deviation unit. In this case, it's going to be 9 milliliters. That's the distance from the mean, and to show it's the distance from the mean, we're going to subtract it from the mean. And we're going to divide it by our standard deviation. All right, let's have a look what that would be. So we've got a 9 minus 7, which is the mean, and we're going to divide it by the standard deviation, which is 1.5. All right, let's have a look what that comes to. So I'm just going to use the trusty old calculator. So I'm going to go 9, take 7 off, and I'm going to divide it by 1.5. And I get 1 1/3. Well, I'm actually going to break with tradition here and actually write a decimal. And the reason I actually want a decimal and not a fraction or a mixed fraction is because the normal distribution tables don't really deal in fractions so much as they do decimal. So I'm actually wanting 1.3 recurring. Well, let's see if we can find 1.3 recurring. Well, here are the z values. So here's 1.3. There it is. So I'm going to take a ruler. A ruler is very useful here because I can line these up perfectly and make sure I don't mess this up. So I want 1.3. So here's my 1.3. Then I want 1.33. Here's 1.33. Here it is. That's my value. But I want 1.33 and another 3. There it is. And it's going to be a 5. So I'm going to have 4.082, and that last digit, I'm going to add to that last digit a 5. So it's going to be 0.4087. So probability is going to be equal to, the probability will equal 0.4087. Now you want to write this correctly. You want to say, the probability is going to equal something to do with this. But we haven't finished, so I'm not going to actually do that just yet. we know that the Z value of what we've really found, is the Z value of 1.3 recurring is 0.4087. That's really what we found. But we don't actually want that, because you see, really what we found is not this area here. We've always, remember, the whole point of the Z value is how far in standard deviations the unit we've got here is away from the mean. In other words, we haven't found this bit here, we found this bit here. We found that distance here, not this distance on the other side. So to find the distance on the other side, all we have to realize is this side is exactly 50%, or if you like, 0.5. The other side is exactly 50%, or in other words, also 0.5, and the probability of getting the whole lot, of course, is 1.0. So we need to take the value here, which we found, we need to subtract that value from 0.5, and that'll give us the bit, we found this value here. If we subtract this value here from 0.5, that will give us this bit here. Sorry, I've got to make sure I say it the right way. All right, so let's do that now. So here we go. We've got so the probability of Z being, shall I say, greater than 0.4087. And remember, you probably are going to put a leading zero there. I tend not to do that for the reasons we've talked about. And that's going to equal 0.5 minus 0.4087. Let's see what that comes to. So I've got, I've got the wrong thing on the calculator. I'm just going to get rid of that. So it's 0.5. I'm going to take 0.4087 off that. And I'm left with, why does it give me 0? Okay, that's a useless calculator. Now, I want to show you actually on a calculator so you can see the actual point I'm making. Hang on 1 second. Sorry. Children, they took my calculator. I just blame them. It's just so much easier than actually taking responsibility myself. So 0.4087, so I'm going to take my 0.5, subtract my 0.4087, and I get 0.0913, and equals 0.0913, or if you like, 9.13%. So in other words, and you want to put a sentence here, I'm not going to do that, and I'll let you do that, but you want to say the probability that, what was the question? Let's have a look. Yeah, the probability that over 9 milliliters comes out of the dispenser will be 0.0913. And that is the answer.